Hello, everybody. A very good morning to all of you. So, shall we begin our lesson? So, we are going to continue from where we stopped previously. So, previously we stopped at chapter 5, section A. So, now we are going to continue with the section B, which is the structure questions. So, with that hesitation, let's begin our lesson. So, if you like my lesson, help me to click like on this video. And if you want to receive any further notification about the new video that I uploaded on my YouTube channel, so please subscribe. Okay, so with realization, let's have a look at the questions given. So number one, decomposition of dinitrogen pentoxide N2O5 to become nitrogen dioxide NO2 and oxygen gas O2 is shown in the graph below. So this is the graph of long concentration against time. Now, student, you have to know by yourself that how do you determine the order of reaction by looking at the graph alone? So now, if you are looking at the graph of concentration against time, okay, then you are looking at the zero order of reaction. If it is a second order of reaction, then it should be concentration, 1 over concentration against time, which will get you a positive linear gradient. And in this graph, this is a long concentration against time, which is a negative linear gradient. So this is trying to tell you that the order of reaction with respect to N2O5 is first order. Okay, so that is what you can tell from the graph. And in here, you can what you can also get from this graph is you are also able to calculate the gradient in here. So I straight away shows you on how to calculate the rate constant in here. So all you have to do is just get the gradient line for this. Okay, so once you get the gradient line, then you'll be able to calculate the rate constant for the graph. For rate constant for this reaction. Okay, so that is generally how you calculate the rate constant and also determine the order of reaction from this graph. Okay, so let's continue to the questions, shall we? Okay, so let's have a look at question number 1. From the graph above, construct a balanced equation for the decomposition of N2O5. So the question already gives you that N2O5 dinitrogen pentoxide will decompose to become nitrogen dioxide and also oxygen gas. So this is the balanced equation. So 2N2O5 gives 4NO2 plus O2. So students, you should be able to do this on your own when they already give you what are the products for the reaction. Should you memorize this equation? Usually STPM, they will give you the ideas of how to get the products of the reactions. Okay, so generally you don't have to memorize, but it will be good if you manage to memorize 1 or 2 decomposition equations. Yeah. Then B, determine the order of reaction with respect to N2O5. So as I already mentioned just now in the introductions, so you can get, when you get the graph of long concentration against time, and it gives you a negative linear gradient, then it is the first order of reaction with respect to N2O5. So based on the first order of reaction, you're able to write C, the rate equation for the decomposition of N2O5. So you have to write as rate equals to K, concentration of N2O5. So since this is the first order, you don't need to write power of 1 here. So straight away express your rate equation in a form like this. Then D, calculate the rate constant for the reactions. As I already mentioned also just now, that you can calculate the rate constant of the reaction from the gradient of the graph when you have the graph of long concentration against time. So you get any 2 points inside there, okay, which gives you the gradient of the graph. And you'll be able to calculate and get your gradient as 1.67 times 10 power negative 3. Unit is second minus 1. Yeah. Okay, so you can express either is 2 or 3 significant figure. In STPM, usually for such graph, because they already give you the graph is not plotted by yourself. So there will be only a small range of acceptance for this answer. So in this case, if you get somewhere between 1.65 to 1.7, so they should be able to give you 1 marks for the answer in here. So if you get outside the range, that means somehow in some way you must have determined wrongly the graph in here. Okay, so they will not give you any marks for the answer. Okay, and finally for E, calculate the half-life of the decomposition of N2O5. So can you determine half-life from the graph? Actually cannot. However, because this is the first order of reaction, you can straight away determine the half-life of reactions by using the half-life equation for the first order. So you must memorize this equation where we have T half is equals to 0.693 over K. So you substitute into the equation. So you get 0.693 divided by 1.67 times 10 power negative 3. You should be able to get 415 seconds. However, if you use 1.7 times 10 power negative 3, then your answer should be 407.7 seconds. Okay, so that is how you should be able to get your answer for question number 1. So with analyzation, let's have a look at question number 2. In a catalytic experiment involving Haber process where N2 plus 3H2 give 2NH3, name the catalyst and explain the type of catalyst used in this Haber process. So you must memorize somehow some of the basic chemical reactions applied in industry. For example, Haber process. So Haber process, you use iron as the catalyst. Then you also should memorize for contact process. So contact process, you use vanadium 5 oxide. Okay. Another one is Oswald reaction. So Oswald reaction is to use ammonia to oxidize to become nitrogen monoxide, sorry. And the catalyst in here is a platinum. Okay. If possible, also memorize their condition. For Haber process is 450 to 500 degrees Celsius at 200 atmosphere in this case. Okay. And the question also asks you to explain the type of catalysis used in this reaction. So you should know that there are two types of catalysis. One is a homogeneous catalyst, another one is heterogeneous. What is the differences between a homogeneous and heterogeneous catalysis? A homogeneous catalyst is where reactant and catalyst are in the same state of matter, whereas in this case, since the reactants are gases, and the catalyst is solid. So this is the type of heterogeneous catalyst. So why is it a heterogeneous catalyst? Because catalysts and reactants are in different phase or in different state of matter. Okay, so that are the points that you have to mention. What are the catalysis for the Haber process? Then B, propose the rate equation for the uncatalyzed reaction of the Haber process. Now, if you look at here, there is a very highlighted word, is an uncatalyzed reaction. So why they have to specifically say that this is an uncatalyzed reaction? Because in an uncatalyzed reaction, this is a reversible reaction. So reversible reactions only have single step. Either it's a forward reaction from N2 plus 3H2 give to NH3, or backward reaction, 2NH3 give N2 plus 3H2 here. So since it is a single steps reaction, stoichiometric coefficient can be used as the order of reactions in here. So that is why the question in here stress that uncatalyzed reaction, because they want you to realize that the order of reaction can be taken directly from the stoichiometric coefficient. So how to express the rate equation in this case? So you have to express as rate equals to Kn2 times H2 cubed. C, if the rate of reactions was measured at rate equals to dNH3 dt equals to 2.0 times 10 power negative 3 mole per decimeter cube. Second, what was the rate of reaction expressed in terms of N2? So the way of how we express the rate equation here, dNH3 dt equals to rate equals to dNH3 dt is the most basic way of how to express rate of reaction for a chemical reaction. Okay, now you get a positive sign because NH3 is a product. So when NH3 is a product, so that is why the rate is a positive rate because concentration of the product increase with time. Whereas for nitrogen and hydrogen, they are reactants. So when they are reactants, the concentration will decrease with time. So when concentration decrease with time, that is why you get a negative rate. So how are you going to solve in this case? So you have to express the rate for nitrogen and ammonia at the same time, where you can straight away express as rate equals to half of the dNH3 dt equals to negative dN2 dt. So in here, since you form two ammonia, so that is why 1/2, okay? So dNH3 dt equals to dN2 dt. So the question already give you that dNH3 dt is 2.0 times 10 power negative 3. Substitute this value straight away to here, dNH3 dt. So you can straight away get dN2 equals to negative 1/2, 2.0 times 10 power negative 3. So the negative in here, you move to here, okay? And finally, press your calculator, you get the answer as negative 1.0 times 10 power of 3 mole per decimeter cube per second. So in here, you get a negative rate, as I mentioned just now, because concentration of the reactant decrease with time. Then for the number 2, hydrogen, so you express in the same manner. So rate is equals to 1/2 dNH3 dt equals to negative 1/3 dH2 dt. So dH2 dt is equals to negative 3/2 times 2.0 times 10 power negative 3. You get negative 3.0 times 10 power of 3 mole per decimeter cube per second. So the unit of the order of reaction, please don't forget. All the rate reaction have the concentration of mole per decimeter cube per second. So that is for number 2. Immediately we move to number 3. Decomposition of aqueous hydrogen peroxide can be accelerated by adding a small amount of acidic solution to sodium bromide. The alternative steps of the addition of acidic solution is shown below. So step 1, 2Br minus plus 2H2O2 plus 2H plus give Br2 plus 2H2O, whereas step 2 is Br2 plus H2O2 give 2Br minus plus 2H plus O2. A, write an overall equation for the above exothermic reaction. So in here, you should be able to know how to balance between the two equations in here. So if you cancel Br2 cancel with Br2, and then 2H plus cancel with 2H plus. Okay. And then 2Br minus cancel with 2Br minus. So at the end of the day, what would you get? You get 2H2O2 give 2H2O plus O2. So that is how you write an overall equation based on the steps given to you in the question. So B, state the role of acidic solution for the decomposition of hydrogen peroxide. So since acidic solution is added in the beginning, but at the end it doesn't form as a product in here. Therefore, H plus in here act as a catalyst. C, sketch and label energy profile for the catalyzed and uncatalyzed reaction. So how to determine which one is a catalyzed, which one is an uncatalyzed reaction? So this one, the question already says that the equation can be accelerated by the addition of a small amount of acidic solution. So in another word, this step 1 and step 2 are catalyzed reaction, whereas this one, the answer in A, is uncatalyzed reaction. So if you look carefully, catalyzed reactions are made by 2 steps, whereas uncatalyzed reactions are single-step reaction. So when you have a 2-step reactions, and this question also already states that this is an exothermic reaction. So you have to be very sensitive on all the words inside the questions. So the question already tells you that this reaction is exothermic. In another word, energy of the reactant is higher than the energy of product. So at the end of the day, how should you plot your graph? So this is the graph of uncatalyzed, this is the graph of catalyzed reaction. Okay, so I'm going to highlight it here. Okay, so you have to label. So this is a catalyzed reaction. Okay, you have to label. Sorry, you shouldn't stop it all here. Okay, you should stop at reactants. Sorry for the wrongly labeled. I will label again here. Okay, and this is the catalyzed reaction. Catalyzed reaction, we use different color. So straight away from the reactant to the peak in here. So this is the catalyzed reactions here. Okay, okay, and you label accordingly, stating that this is catalyzed. This is catalyzed reaction. Okay, and then you also notice that inside a catalyzed reaction, it is made from 2 loops, whereas uncatalyzed reaction is made by 1 single loop in here. So what does it indicate when you have the 2 loops and 1 loops, and how do you determine? It is determined from the number of steps. So since catalyzed step is made of 2 steps, so you have 2 loops in here, whereas uncatalyzed reaction is made by 1 single step. So therefore, there is only 1 loop in here. So this is how you are going to determine when there are 2 loops, when there are 1 loop in here. So this is how you are going to draw the energy profile for the reactions. Then we straight away goes to question number D. State 2 observations of the catalyzed reaction. So if you notice carefully from the catalyzed reaction here, you add bromide ion. So bromide ion is a colorless solution, and then you form bromine in step 1, which is brown in color. And then bromine suddenly disappear back to the bromide ion. So you see the observations number 1 in here is that colorless solutions turns to brown, then decolorize again in here. So this is the first observation. In the second observation, you also notice that you form oxygen. So how do you observe oxygen? You observe oxygen as bubbling. So that is why this is the second observation. So as for answer, effervescence or bubbling is observed. Second answer in here is colorless solution turns brown, then to colorless again. So this is the two expected observations for the catalyzed reactions in here. So with that, that is for question number 3. Immediately we move on to question number 4. Cyclobutane decomposed into butene through the ring open of cyclobutane according to the equation. C4H8 gives CH2 double bond CH2CH3. Rate constant for the decomposition is 15.12 second minus 1. So you must be very alertive on the units of the rate constants in here. So the unit of the rate constant in here is second minus 1. So what can this information gives you? This information can tell you that the order of reaction with respect to C4H8 is the first order of reaction. Therefore, when you write the rate equation for the decomposition, you have to write as rate equals to K C4H8. Sorry, I typed error. C4H8. Supposedly C4H8. Okay, so number 2. Calculate the half-life of the cyclobutane. So now when you know that it is a first order of reaction, you can straight away use the half-order equation for the first order. So 0.693 divided by K. So 0.693 divided by 15.2, you should get 0.458 seconds. Then number 3, if 1.0 mole of cyclobutane is introduced into a 1 decimeter cube vessel, what is the concentration after 2 half-life? So after 2 half-life, you decrease 2 times by half. Okay, so it's 1.0. Actually, this 1.0 is mole. Okay, and then this 1 is decimeter cube. So that is why substitution in here is 1 mark. Okay, so you have to express in terms of concentration. Okay, so you get 0.25 mole per decimeter cube. So this is how you get the 2 marks in here. And finally, B, butane form can be hydrogenated according to the equation below. CH2 double bond CH2CH3 plus H2 give nickel at 180 degrees Celsius to give butane gas. State the role of nickel in the reaction above. So the reaction above of the nickel in here act as a heterogeneous catalyst. Why does it act as a heterogeneous catalyst? Because it gives the lower activation energy. You might also, if you want, you can also add that this is a heterogeneous catalyst because nickel and reactants are in different state of matter. Okay, you can also add that as the answer in here. Okay, so that is how you answer for question number 4. Immediately we move to question number 5. Sulfuric acid is used in many industries processes of major importance. The first stage of the manufacture of sulfuric acid is to pass air over burning sulfur. The emerging gas has the following composition by volume. You have 10% sulfur dioxide, you have 0.2% sulfur trioxide, oxygen 10%, and nitrogen 79.8%. So A, write the equation for the sulfur burning in air. So when sulfur burns in air, you first form sulfur dioxide. B, the emerging gases is passed through a catalyst maintained at 450 to 550 degrees Celsius in the reaction chamber. Name the catalyst used in the contact process. So as I already mentioned to you in the beginning of the section B explanation, I've already told you that you have to memorize some of the very basic catalysts used in the industrial processes. So in the contact process, you have to use vanadium 5 oxide. C, sulfur trioxide is formed in 98% yield. 2% of sulfur dioxide remain unconverted. So according to the equation, 2SO2 plus O2 give 2SO3. High yield is only achieved under certain condition. After each condition, explain why this led to an increase in the yield of sulfur trioxide. Number 1, there is an excess of the air in the reactant of the gas chamber. So if you look carefully at the equation in here, 2SO2 plus O2 give 2SO3. Why O2 need to be excess is when you have O2 in excess, concentration of oxygen is high. So when concentration of oxygen is high, so equilibrium will shift to the right in here, producing more SO3. Okay, so this is the reason why you need excess air in here. And then number 2, the catalyst needed to be cool. So under high temperature, V2O5 will tend to decompose to form other substance. So that is why it has a tendency to be cooled. So this one is a very hard to get marks because you have to know the reason why V2O5 is applied in here and what is the effect if the V2O5 is heated at a high temperatures, because eventually it will decompose. Okay. And then number 3, air used to burn sulfur must be as clean as possible, because if you have to use other things, so because air contain mainly oxygen, okay, so if you burn oxygen with other species, therefore they will form other side product, okay, and when it form other side product, there may be a chances to poison the catalyst. So that means the catalyst will also cause the formation of different side products in here. So that is why you require oxygen to be as clean as possible. D, in the modern plants, nearly all of the SO2 and SO3 mixture is absorbed, but 0.05% by volume of SO2 may allow to pass by the atmosphere through a chimney stack. Give 2 reasons why SO2 should not be discharged into atmosphere. So why it cannot form this one. So as you know, one of the main concern of the release of sulfur dioxide gas to the environment is the production of acidic rain. So when you have acidic rain, when it falls, it will cause the soil to become acidic. It will also corrode the building and the structure. Okay, so that is why. So SO2 is toxic and hazardous and will cause various health problems. So SO2 will oxidize to SO3 and produce acid rains. Okay, so these are the 2 reasons why sulfur dioxide should not be discharged into the atmosphere. That is for now question number 5. Immediately we go to question number 6. Cyanohydrin CH3,2COHCN can be made by reacting propanol with acidified solution of sodium cyanide. The mechanism of the reaction can be described as below, where you have CH3,2C double bond O plus H plus gives CH3CH2COH plus. This is a slow step. Then CH3COH plus Cn minus gives CH3COHCN fast step. Based on the mechanism above, explain and construct rate equation for the reaction between propanol and acidified solution of acidic cyanide. So a rate equation is written based on the slow step. Okay, so rate is equals to K CH3 2CO time concentration of the hydrogen. So why is it that the step 1 is used as the fundamental to write the rate equation? Because the slow step is the rate determining step. Number 2, what is an intermediate? Which of these substances in the above mechanism act as the intermediate? So in here, substance that appear in the mechanism reaction but not in the overall reaction. So in here, it is the CH3COH plus act as the intermediate. Okay, so because it only appears during the reaction but will not form as a product in here. Okay. So that is the 2 mark. And then number 3, from the mechanism, construct an overall equation for the reaction. So you can cancel in between CH3,2OH. Okay, cancel and cancel. So at the end of the day, what do you get? So at the end of the day, you get CH3,2C double bond O plus H plus Cn minus gives CH3,2COHCN. And finally, sketch the energy profile for the reaction between propanol and acidified sodium cyanide, which is an endothermic process. So the question already says that this is an endothermic, so reactant must be lower. Okay, this is the product. And if you can see in here, there are 2 loops in here. Why are there 2 loops? As I already explained just now, since this reaction is made of 2 steps, so that's why you have 2 loops in here. So that is how you solve for question number 4. By the way, if you want to sketch the energy profile, okay, so make sure that it is a graph of energy against reaction coordination. Energy against reaction coordination. Usually, this labeling the axis will give you 1 mark here. Okay, and if possible, you also show that this is an endothermic reaction. Okay, you draw the arrow up. And then this is the catalyzed activation energy. Okay, just draw whenever you feel that it's necessary. So this is the EA. Okay. Okay, and this is the delta H. So delta H is positive. Okay, so and then if you want, you can also label what are the reactant and what are the products in here. Okay, so try to express as complete as possible in here. So that is for question number 6. Then we go to question number 7. Mechanism of the oxidation of iodide ion by hydrogen peroxide was suggested below. So you have H2O2 plus I minus give H2O plus IO. Then you have H plus IO minus give HIO. And then HIO plus H plus I minus give H2O plus I2. So write an overall equation for the reaction. So you have to compare between the 3 equations. So let's together find out which one and which one can be cancelled. So eventually you see that IO minus can cancel with IO minus. What else? HIO can cancel with HIO. So at the end of the day, what do you get? You get H2O2 plus 2H plus 2I minus give 2H2O plus I2. B, write the rate equation for the reaction above. So you determine based on the slow step. Okay, so the slow step in here is H2O2 times I minus. So rate is equals to K concentration of H2O2 power of 1, I minus power of 1. So why you take this step? Because slow step is a rate determining step. Number C, data obtained from an experiment about the oxidation above is shown below. Assume the data is consistent with the mechanism suggested. Complete the table below. Okay, so how are you going to do? So as I already mentioned to you, you have to learn how to write the rate equation based on the substituted answer. So you're going to write experiment 1, 2, 3, 4. So rate constant is equals to K 1.0 times 10 power negative 4, 0.1 times 0.1. So you get 1.0 times 10 power negative 2. So this is taken from the first one. Okay, this is taken from the first one. So for A, so 2.0 times 10 power negative 4 equals to rate constant K, 1.0 times 10 power negative 2 multiplied by the A concentration of H2O2 times concentration of H plus in here. Okay, so as already stated earlier, our rate equation just now, rate equals to K concentration of the H2O2 times the concentration of I minus. Okay, so you are going to write based on these equations in here. Okay, you're going to write based on the equations in here. Okay, so you substitute accordingly. So you get A equals to 0.2 mole per decimeter cube. Okay, and then for the B, okay, so you substitute 1.0 times 10 power negative 4 equals to 0.1 times 0.2 times B. So you substitute and then you'll get your B at 0.1. Okay, so that is how you get your A and B there. D, what is the overall order of reactions in here? Since rate is equals to K H2O2 times I minus, both of them are first order, so the overall order is second order. So with that, I believe that is all for the 7 objective questions that I already shared with you. So hope you can understand what I tried to express to you today. So if you have any questions, feel free to drop by in the comments. I'll try my best to answer as fast as I can. So I'm going to stop for the objective structure questions for today. So we are going to continue with the essay questions on the later on video. Okay, so that's all for class today. See you all later. Bye.